We rely on brakes every single day, but I've never really stopped to think about what makes them actually work. It feels like magic, but there's some serious science packed into a brake pad.
It's a fascinating world, and at the very core of it are fibers. They're the unsung heroes in what are called friction materials, the stuff that actually creates the stopping power.
Fibers are absolutely crucial in friction materials, fundamentally boosting their strength, performance, and durability through mechanical reinforcement. For this to work effectively, these fibers need specific traits like thermal stability, good dispersibility, and appropriate hardness, and the industry has moved from hazardous asbestos to much safer alternatives.
Precisely. Without these reinforcing fibers, friction materials simply wouldn't withstand the immense forces and heat generated during operation, leading to rapid failure. They would literally crumble.
So, we understand why fibers are so vital and what makes a good friction material fiber. But what types of fibers are actually being used today, and how do they differ?
Oh, it's an incredibly diverse field. You've got a whole menu of options to choose from depending on what you need.
Today's friction materials utilize a wide array of fibers, broadly grouped into synthetic and polymer types, natural, mineral, and specialty fibers, and importantly, the substitutes for banned asbestos. Synthetic choices include glass, aramid, carbon, and acrylic fibers, while natural and mineral options range from cellulose and basalt to ceramics and paper-based fibers, with metals like steel and copper also playing a role.
It's fascinating how each category offers a unique balance of properties. For instance, glass fibers are cost-effective and heat-resistant, while aramid fibers, with their curly structure, excel at uniform distribution, which directly impacts the consistency of the friction material's performance.
That covers the main types of fibers and their general characteristics. Now, let's dive a bit deeper into the specific roles these fibers play in ensuring both performance and safety in friction applications.
This is where the real engineering genius comes in. It's not just about adding stuffing, it's about precise functional design.
Delving into their functional impact, fibers are key to enhancing the overall strength and performance of friction materials, providing the mechanical strength needed to withstand forces during production and use, and preventing damage to ensure durability. They also need stable chemical and thermal properties, a large surface area for binders, good dispersibility, moderate hardness, and importantly, good environmental performance.
The good dispersibility and moderate hardness requirement is particularly interesting. It directly addresses the common issues of uneven wear and that awful squealing noise in brakes, showing how fiber selection is a precise engineering challenge.
Exactly. And when we consider the shift from asbestos to alternatives like sepulite and brucite, it's not just about finding a replacement, but ensuring these new materials meet all those essential requirements: thermal stability, dispersibility, and environmental safety, which is a monumental leap in material science.
That's the perfect point. It shows the evolution of the entire industry.
So, we've covered the essential roles, the types of fibers, and the properties they need. It's clear that the careful selection and integration of fibers are paramount to creating effective and safe friction materials. To wrap up, could you summarize the biggest takeaways for us?
Absolutely. First, fibers are the essential backbone for strength and durability. Second, the key properties we're always looking for are thermal stability, good dispersibility, and a balanced, moderate hardness. Third, the palette of fibers is huge, from synthetics like glass and aramid to natural options and even metals. And finally, and maybe most importantly, the industry has successfully moved on from hazardous asbestos to safer inorganic alternatives like sepulite and brucite, which is a huge win for health and safety. It's all about understanding the role of these fibers, their properties, and the ongoing search for safer alternatives.